Welcome to solverfy.
All right, for this problem, we need to compute the total distance traveled by the vehicle by calculating the area under the red-brown graph of the velocity versus time. And the way I did it is I split the area, the total area, in this fashion. We have a triangle, base 15, height 50, plus a rectangle that goes from 15 seconds to 40, height 50, plus a triangle that goes from 40 to 50, and the height 50 as well. If you add up all these three areas, you should get 1875 meters. The bases of the triangles, of the geometrical objects are in seconds, and the heights are in meters per second. Then for the next graph, or for the next question, we're asked to compute the distance the car goes between 10 and 40 seconds. And the way I did that is that the area between 10 and 40 seconds is equal to the area between 0 and 50 minus, this is the sum of these two areas, 0 to 10, plus the area between 40 to 50. And again, after you compute those areas, you should get 1475 meters, or thereabouts. Then question C asks us to draw the graph of the acceleration versus time. And we can do that from the graph of the velocity versus time, because we know the velocities are 15, but from 0 to 15, from 15 to 40, and onwards. From 0 to 15, the velocity or the acceleration is about minus 3.3, about positive 3.33, and that is computed by taking the ratio of 50 minus 15, and this is 3.33 meters per second squared. So the acceleration is, the graph is here, then it drops to 0, it's constant, is 0 from 15 to 40, and then from 40 to 50, we compute the same way as from 0 to 15. And then the difference is that we got a negative acceleration, and this comes out to be minus 5 meters per second squared. So we're here 1, 2, 3, 4, 5 negative. So the acceleration up to 50 will be here. And that is the graph of the acceleration versus time. For the next question, or D question, we're asked to write an equation for the position as a function of time for three segments of the motion, 0A, AB, and BZ. So D, 0A encompasses the time between I think about 0 and 15 seconds, 0 to 15 seconds. And here, the position from 0 to A is nothing more than the acceleration, which we computed above, 1/2 the acceleration times square, or 1.67 t squared. The position from B to A encompasses the time of about 15 to 40 seconds. And the position from B to A, remember we're moving now under constant velocity, acceleration is 0. So the equation should be the initial velocity in that time, which is 50, the time plus some initial position that we don't know yet, but we can calculate. We can compute that position by inserting, we can find out what this value of this initial position is at t equals 15 seconds. So 50 times 15 plus xi should be the distance traveled from 0 to 15 seconds. And remember, that's just the area of that rectangle, 1/2 15 times 50. And after you solve for xi should come out to be minus 375. Negative 375 meters. So the position between A and B is 50t minus 375. And then we need to compute the final position from B to C, and in this time, in this phase of the path, we're in the 40 to 50 seconds, and we're moving here with constant negative acceleration. So we know that this is going to be 1/2 acceleration t squared plus some initial velocity times the time plus some initial position, which we don't know yet. We don't know what this initial are, but we can compute. Remember that we computed acceleration in this part of in this right triangle. It was -5, if you remember. So this is going to be equal to minus 2.5 t squared plus some initial velocity that we don't know yet plus some initial position. We don't know this guy at all yet, but we can compute it. And we compute it as such. Let's take the derivative of x bc versus time, and we get minus 5t plus vi. And let's compute that now. Let's calculate that at t equals 40 seconds. At t equals 40 seconds, we will have minus 5 times 40 plus vi. And from the graph, we know that this has to be equal to 50. Therefore, the initial velocity is equal to 250 meters per second. So now we're getting closer to the final answer, because now we have that the position from B to C is equal to minus 2.5 t squared plus 250 t plus some xi. We don't know yet. We don't know, but we can, again, compute the position at 40, at t equals 40 seconds. So we got minus 2.5 times 40 squared plus 250 times 40 plus xi. And from the graph, we know that this has to be equal to the area of two rectangles, of two geometrical objects. This area, the first triangle, 15 times 50, 1/2, 15 times 50 plus 50, 40 minus 15, that area. And this comes after you multiply above. You're like, this comes out to be 6,000 plus xi equals to 1625. So from that we know that xi better be minus 4375. Therefore, the position from B to C is minus 2.5 t squared plus 250t minus 4375. I hope you enjoyed